Welcome to the Digital Enterprise Society podcast, addressing all aspects of the digital enterprise, inspiring connection without boundaries and creation without limits. Thank you for tuning in. Here are your hosts, Thom Singer and Craig Brown.
This is the Digital Enterprise Society podcast. This podcast addresses strategies to enable enterprise transformers and decision makers to understand how digital tools and techniques deliver superior results in the global competitive marketplace. My name is Thom Singer, and I have had the honor to co-host this show for almost 4 years with Craig Brown. Craig is an industry veteran and a former PLM leader at General Motors. Craig continues to serve the community of PLM as an advisor and a mentor. Hey, Craig, how are you today?
I'm great, Thom. And you know what? It's good to see you here on our recording. But it was even better to see you in person a few weeks ago. And we ran into our guest today at that same event. And it's just fabulous to get back to the way we were before the pandemic. So it's great. And I'm looking forward to today's podcast.
And that was an awesome event that the Digital Enterprise Society held outside of Detroit. And in fact, I would say that if you did not attend that event in November, you should be paying attention to the Digital Enterprise Society calendar, because there'll be more events in the future and you don't want to miss the interaction, the conversation, the community, and the collaboration that took place at that event. So pay attention, because there'll be more things coming down the pipe. Like you said, today's guest was there, but he has been a guest on this podcast over the last 4 years, 2 other times. He is one of the few people. He gets like on Saturday Night Live, they have that 5-time host jacket. We should have like a 3-time guest jacket, because there's only been a handful of people who have been here that many times. But our guest today is Patrick Hillberg. Now, he is a professor at Oakland University, where he teaches managing product life cycles, and he was the lead architect, a lead architect at Siemens PLM for a long time, and then he headed up their academic and workforce development plan there at Siemens PLM. And today, he teaches, he shares, he volunteers, he gives back, and we are glad that he comes to share his knowledge here. So Patrick, welcome back to the Digital Enterprise Society podcast.
Thanks, guys. Happy to be back. You know, I sometimes, like this, I'm asked to speak publicly, and that's never a problem. The problem is getting me to stop speaking. Right? So,
well, I'm sure we're going to have a vibrant discussion today. Craig, I'll let you take the reins here.
Okay. Well, so an interesting topic that keeps coming up everywhere is systems engineering and how we've all got to be better systems engineers. And in some of our discussions over the past months, a few people have pointed out the shortcomings of systems engineering. And I thought it would be good to have a debate today a little bit about, what's wrong with systems engineering. And so Patrick introduced this notion recently to me about, sometimes system engineering causes dysfunction. And I would like, Patrick, for you to describe what you mean. And then there's probably some new terminology along the way that we need to teach our audience. So why is system engineering a potential pitfall?
Sure. Well, first, let me start by saying that I have a master's, a doctorate, and a faculty position in systems engineering. So I certainly have committed myself to that.
So you know the shortcomings.
Yes. Yeah. That's the next thing that I'll say, is that even then, I'm not 100% sure what it means. Engineering is a subsystem within the organization. So I don't know that we can truly talk about a system if we're limiting ourselves to just the engineering role. And I can go on in that. There's the idea that the system is fully encompassing, et cetera, but I'm sorry, I digress. So I teach this course, which I call Managing Product Lifecycles, and I am looking much larger than PLM. I'm looking, which tends to be a technology thing. And we talked about that in a previous podcast. I teach the students who take the class are primarily engineering managers and then also systems engineers in a graduate level program. And there are 3 aphorisms that define the class. And the first aphorism is that decomposition creates dysfunction.
Okay. All right. So help us.
Sure.
A lot of us that have been in the business a long time, we get what decomposition means, or at least the definition of it. But help the audience to describe what decomposition means.
Sure. So it's hard to understand the entirety of a product, in particular of just a product, much less the entirety of the entire product life cycle. So if you think of an automobile, it has something around 20,000 parts in it, and the radio needs to work and the tires need to work and all of this. And we tend to break up that work into different groups. So we'll have experts for radio technology, we'll have experts for wind resistance and aerodynamics, and we'll have experts for engines and how fluid flows through an engine and all those sorts of things. But the driver and the passenger, the occupants of the vehicle want the entire thing to work together. And as we break up the work within the organization into individual groups, then we tend to lose track of what the entirety of the thing is. So there's a slide that I use when I give public talks, and I talk about, I put up 3 pictures, one of an electrical engineer, one of a mechanical engineer, one of a software engineer. And then I ask, clap twice if you have a degree in one or the other of those 3 things. And then I ask, and I'll usually get a lot of mechanical engineers. And then I'll ask who has 2 degrees in independent things. So both a mechanical engineering degree and an electrical engineering degree, or electrical. You might see electrical and computer science. It's a little more likely. You almost never see mechanical and computer. And yet, particularly if we start thinking of autonomous vehicles, we need the mechanical and the electrical and the software to all work together. However, within the organization, the mechanical engineers tend to report up to one director or one executive director or VP, and the electrical will report to a different one, and software will report to a third one, and they all tend to be running on different budgets. And you end up in this situation where basically there's finger pointing, where the electrical was supposed to do something. Computers assumed the electrical was doing something that they didn't actually do. So
these disciplines exist, and corporate leaders have to build organizations somewhat based on skills. I'm an aerospace engineer, and one of the things I learned early in my career is we're the ones that had to meld it all together, because those other silos, while they were expert at whatever it is their discipline was. And so my point is isn't this partly an education problem? And not to pin it on you guys in education, but isn't that the problem, is that we're not cross-discipline training? I realize that makes it harder to learn everything, but is that part of the problem, is we just teach them wrong? Or not enough?
Absolutely. So first, to your point, there's a lot of efficiency in deeper and deeper level of skills. Mm-hmm. However, you start losing that cross-discipline aspect of things, and the academic system is absolutely in that case. It is very difficult. It's almost impossible to get a master's in electrical engineering unless you already have a bachelor's in electrical engineering. The qualifications for getting into some of the quote unquote hard engineering programs, so mechanical and electrical, not sure about computer science, is that you have an undergraduate in that field. So what you are getting more and more narrowly defined. You're moving higher and higher up the mountain, but that mountain is now a narrower peak. So you really don't understand what's going on the other mountain. Yeah, and that is absolutely coming out of the academic system. So
then this decomposition, the componentization of solving a problem is partly your education background. I remember at GM, we were having this huge debate about the systems engineering department. And at the end of it all, we said, okay, every engineer is a system engineer. In other words, you had to, even though if you were trained in mechanical or whatever, you had to understand your interfaces, 2 interfaces out. So the one you immediately talk to and the one that they talk to. And sometimes that would be the other discipline, right? Electrical or embedded software if it was communicating, right? So maybe system engineering is a skill and not a discipline, maybe.
No,
and would that help the componentization problem?
I think you absolutely make a good point. And I will say this about my discipline of systems engineering, is that master's program does tend to allow, across the different universities, that program does tend to allow multiple incoming streams. So most of my students have mechanical engineering undergrads. Very few have systems engineering undergrads. I'd say 2/3 are mechanical engineers, and then the other third split between electrical and computer science and kind of a smattering of other things. So the systems programs do recognize that, and they're not trying to make say, mechanical engineers to become better mechanical engineers. They're trying to get those engineers to look across.
So if you're listening to this and you want to know what to do different, so the title of part of what we're talking about is decomposition creates dysfunction. All right, if I want to solve the dysfunction, and the evidence of dysfunction is all over the place, right? You have an unexpected quality spill, or you didn't meet a customer demand, though you followed all the requirements, right? So these are all examples of dysfunction. What can the individual do to help this problem? I mean, how do we resolve the dysfunction?
Well, actually, let me go with that question. What can the individual do to solve team dysfunction? I don't know.
Oh, okay. There was a clue in there. Keep going.
And I do think that gets to some extent into the thinking of individuals. If you read some of the management stuff, and I'll bring things from Harvard Business Review into my class, and one of the issues is the performance management programs that most large companies work off of is somebody at the top of the company has a high level goal, and then that gets decomposed to their vice presidents, decomposed to their directors, decomposed to the senior managers and the managers, and then eventually down to whoever in the group, but we're talking engineering at the moment. And then eventually the individual worker is judged against how well did you meet these particular goals that were decomposed at the beginning of the year. And realistically, what we did this year is not that much different than the year before that, and the year before that, and the year before that, and that sort of thing. So what can the individual do? It depends on who the individual is. But probably in the HR department, you start by getting rid of the performance management program. And there is some stuff on that. Suddenly I can't think of his name. Peter Capelli is at, I think, either Penn State or University of Pennsylvania. And he writes frequently on this, that we have this built-in decomposition method that permeates everything. So it's in the schools, it's also in our management structures, and then that breaks down into the organization as well.
So let's go back historically for a second. So
sure.
System engineering for at least one-of-a-kind things called spaceships.
Yeah.
You needed decomposition. You needed somebody to hold the rocket fuel. You needed somebody to design the nozzle. And those disciplines share some things, but the decomposition, you're building a one-of-a-kind thing, and you're doing high levels of risk management that you may not do anywhere else, right? So that's where decomposition was born. You can thank NASA and all that. But then as we applied it to all these other companies, the thing we were just talking about is, discipline, lack of cooperation, or an inability to collaborate. Let's go there for a second. That's where it was overused, probably, right? And so then you're seeing it in how you educate and how people get ready for their advanced degrees. It's already instilled in them that they're in a particular silo.
Right.
and if, gosh forbid, you're one of those guys that gets the alternative degree, you're considered an outcast, right? I mean, you're just unique. You're in a minority. So there's a point in here about, well, there was two things you shared with me, and I think we'll do them in the other order. But the importance of teams, right? Especially diverse teams with different skills. They're the ones that actually really make great products these days, all kinds of products. And so tell us a little bit about how do teams and decomposition work? I mean, maybe they're not compatible. Maybe?
Yeah.
I don't know.
Yeah, I think that's true. But let me put a pin in that because I want to get back to that. I want to cover a little bit of history, though.
Okay.
And I'll take it back. I think the space program recognized a problem that was actually created by Henry Ford in the assembly line.
Okay.
Henry Ford, and I base this on a terrific book, the book that just originally described Lean, called The Machine That Changed the World.
Mm-hmm.
And it goes through the Henry Ford process. And Henry Ford went to interchangeable parts. And with interchangeable parts, he could start breaking up he could create the automotive assembly line. But even before the assembly line, the real thing was interchangeability. So workers became very skilled at building a wheel or building a carburetor or building a piston or whatever, right? And since they had such good repeatable interchangeability, and the product was not immensely complex. I mean, a Model T was not terribly complex compared to the Chevy that's sitting out in my garage. It worked. And then we move into World War II, and suddenly we need to start building a plane a day, and we start needing to build, Liberty ships and all that sort of thing. And people looked around and said, how on earth are we going to do this? And look how great mass production is working. So let's use mass production in World War II. And then you come out of World War II, and actually you come out of World War II and you've got the GI Bill. And this, I think, is where education starts to pick up on the whole decomposition approach. Yeah. Is you have all the GIs who are coming out and they're starting to go to school, and there's a strong desire to elevate the education of the overall. For GI Bill, you're talking America, so the American populace. So what could we possibly use that can educate all these people? I think the number of college students increased fourfold in the space of less than 10 years. So, you need 4 universities for everywhere where there used to be one. And they said, oh my God, look how great mass production is working. So they created a mass production. I mean, the traditional teaching methodology is a mass production teaching methodology where the teacher is this information spigot which spews information at the front of the room, and all the students are all nicely lined up in front of them. And since they all hear the same information in the same way, we assume that all the students are learning the same amount. And then we test them to see how much they learned, and then we put all the blame on the students for not learning as well as some of the other students, right? So that decomposition approach, you see it in the university, but you see it in right on down to let's start with third grade. So I think from kindergarten to third grade, you're trying to socialize the students, but from third grade on, you're starting to teach them, and you start breaking things up. So you've got a separate algebra class. Algebra is taught separately from earth sciences and that sort of thing. It just starts working its way up. Okay, so back to your other question that we put the pin into. How do you deal with teams and decomposition? And
we know teams are successful, right? Some of the most successful companies are the ones that have these really interesting, diverse teams, and they even have non-engineers, right? They have designers, they have users, they have people from marketing, and they're very successful. I'm pretty sure they didn't start with decomposition. I'm pretty sure they started with something else. So what is it about those kind of teams that's working so well?
I'll say what has worked well for me back when I was leading teams at Siemens was using Agile. So we really the traditional systems engineering model that all systems engineers know is this V model. And it looks like a V. And at the top left of the V where you get started, you determine your high-level requirements. Then as you move down the V, you detail those requirements and you decompose those requirements into steps. And then you start moving up the right-hand side of the V, and you start testing all the things that you had decomposed. So in theory, the top right of the V is testing what we initially did at the top left of the V. So that's the traditional engineering approach. However, as we decompose into these different groups, the different groups tend to get pretty isolated in their silos, and they're not overlapping. I mean, they're not recognizing what the others do. So I was part of a team, actually I led a team that said, okay, we're going to do it different. We're going to use Agile, and I'm particularly going to use Agile as a learning-based approach. And the thing that really drove progress on that project was we had a voluntary, we served lunch, right? This helped. We had a voluntary meeting every Friday. That meeting would frequently go 3 hours. We would usually get 50 people to show up, and these are all manager and director level people showing up for a 3-hour meeting. Now, don't get me wrong, they would come in with their laptops and they would do their emails and all that sort of stuff while conversation was going on. But there was a huge amount of team learning that occurred during those meetings. And then Monday through Thursday, we worked on new technology that we were going to show at the next meeting. The thing that was really interesting was, Alice and Betty would be in a conversation and about what they were doing. And suddenly, out of the blue, David or Frank or Xavier, right? X, right? would show up and say, oh my God, I didn't realize you were doing that. That impacts me too.
Right.
And so with this, using Agile as a group learning or a collective learning approach, I think is really important. And it reminds me, it leads to more connections. And I think if you're looking for a personal measure of how you get better at team dynamics and teams problem solving, it's about increasing the number of connections. And I know at times that's difficult. It's been extremely difficult in the past pandemic era. But it's still really important. It's one of the things we noticed when we all got together it's almost 2 months ago now. But the connections matter, even connections outside of your discipline. I mean, maybe that's the point. A really good team has broad connections. Yes, most definitely. Let me get a little technical on this too. This is something we'll cover. So I'll bring it into PLM technology. And I usually stay away from the technology, but I'll bring it into PLM technology. There's something called digital exhaust, and the exhaust is who is talking to who. So, and you can use, so the article that was in the HBR, my class will be reading in the next couple of weeks, was using Slack and email, I think. So you don't look inherently at what the messages are, but you just try to get a sense on who is talking to who. And in the process of doing this, you start building some signatures around, you can have this very tight-knit team that is frequently talking, 5 people who are frequently talking to each other, but they rarely talk outside of that team. That's going to be a very efficient team, but it's not going to be a very innovative team. Yeah, right. Well said. Right. And it's interesting because quite frankly, you can just graph it, by just each person as a node, and you start looking at how many communications are around the node, and you build these lines and arcs and that sort of, and circles and that sort of thing. And I don't know of any of the PLM technologies that are using that. That would be a simple thing that they could add in because they're already collaborating, right? So I'm sorry, Craig, go ahead. So I love chatting with you, but we're going to use up our time. Oh, sorry. So you had one other. It's getting me to stop talking. Yeah. You have one other theme that just, it was like a chime going off in my head, a big church bell. And you mentioned that the way we've done things in the past, right, are not preparing us for the future. So here's a topic. So sustainability has been on everybody's mind. It's very popular now, and people are thinking about when they build a new factory, how do they make sure it doesn't produce more carbon than it displaces or something like that? And I don't mean to degrade it. I just mean it's got an awful lot of buzz around it. You made an interesting point about whether our history is useful for the future. Could you expand on that? Yeah. Use your title. That gets, so there's 3 aphorisms to my course. The first is decomposition creates dysfunction. The second is the past century has not prepared us for the next decade. And why is that? Eventually it comes down to greenhouse gases, but we've never accounted for external costs. So when we build, okay, now I get really even further back in history. You're all influenced by the news cycle, right? Yeah. What occurs to me about your past 100 years doesn't help the next decade. I'm just thinking of water management on the West Coast, and I'll just leave it at that. Just watch the current news cycle. It's like, finally, a miracle has occurred. We're getting all kinds of water, and we can't grab it. It's really sad. I got to tell you something. It's the 18th of January in Detroit, Michigan, and we have not seen snow except for 3 or 4 days in December. Well, yeah, it's really warm here, which is interesting, right? So yeah. But anyways, to your point, our past practices of the past 100 years are not helping us for the next decade. What do we do about that? Right. So we've never accounted for externalities, and the externality in everything, really. I mean, from transportation to energy production to manufacturing to everything else, we have just assumed that we can fill the atmosphere with carbon. And we just don't account for that cost. Well, eventually that cost is coming to us. And to your point, we are seeing that in California right now. We saw that in Pakistan over the summer. Europe had the anomalies in Europe are just huge. Mm-hmm. I mean, the winter's too warm and the summer's too warm. I have a colleague in Nigeria that I talk to weekly, and they're having similar problems to Pakistan of floods. So there's, I don't even want to call it nature, because humans have just so overwhelmed natural effects, but there's physics involved here that we've never accounted for, and that bill is coming due. So for the
and it's not that we don't understand it. I don't think this is a surprise. It's just your point's a good one. We've chosen in the last 100 years to ignore many of these things, just like water management in a drought area, right? You shouldn't ignore it. You should be building for the next big flooding waters. They do come eventually, even if it's a couple decades apart, and then store all that water so you could use it during the next drought, right?
Yeah. A little of that's happening, but a lot of the water in California is flowing out to the sea.
Yeah,
so
right. Which if there's a cycle, it just feeds the next.
Right.
It changes the salinity layer and whatever.
Yeah. Right. Yeah. So in any event, I don't know that the Industrial Revolution was ever sustainable. It created reinforcing growth. I get into systems thinking a lot in my class. You get into reinforcing growth, and it created a lot of reinforcing growth, but we never paid attention to the external costs, and now the external costs are coming due. And I think they're coming due this decade. So certainly not much longer than that. So it's kind of an interesting class, actually.
Yeah. So wrap this up for us then.
Sure.
So we started out with decomposition creates dysfunction. We want systems engineers to be broader through teams, and we want to get ready for the next decade. Give me your 1 minute. Here's what we should do, Professor.
Well, let me bring in my third aphorism, because it kind of gets to that point. My third aphorism is, my students will learn more from each other than they'll ever learn from me. But I get to choose what we talk about, right? So it's about team learning. Okay. We need to have large scale objectives, and then, quite frankly, we need to get together and talk about it. And to be honest with you, that means more meetings. We need value in the meetings. But
we've learned in the pandemic we can do this. The digital tools are fabulous in this regard, whether it's Zoom or all the other PLM tools. So it's not like we were without hope. We just got to get on with making it work.
Right. Yeah, absolutely. So there's some culture change involved, and culture change is hard. So.
Well, yeah, but a pandemic helps, doesn't it? It's like a bolt of lightning from the sky. Wake up. This is your opportunity. Hopefully so. Well, thanks, Patrick. It's always a joy chatting with you, and I look forward to the next time we see each other in person. And Thom, it's back to you.
Yeah, Patrick, thank you so much for jumping in and sharing all of that with everybody here in the audience. And thanks for being a third-time guest on the Digital Enterprise Society podcast. Hey, and to everybody who tuned in and listened, thanks for being here. Be sure that you share this podcast with everyone in your network who works in and around the world of PLM. You can learn more about what you heard today at digitalenterprisesociety.org. We encourage you to leave a comment about the show on your favorite podcast app, so that other people can find us when they're searching for real good information to help advance their careers. And then join us again soon for our next discussion about organizational transformation through the use of digital tools and techniques. Each week, we're here with more thoughts, ideas, and actionable information to help you navigate your career. Thanks for joining us.
You've been listening to the Digital Enterprise Society podcast. Learn more about what you've heard here today at digitalenterprisesociety.org. Join us again next week for more connection without boundaries and creation without limits.